All right, today we are going to be talking about 4.4 and 4.5, which are the congruence shortcut sections. And they kind of go hand in hand, so I wanted to combine them into one video. So to get started, we need to talk about what it means for two polygons to be congruent. Okay, so in order for two polygons to be congruent, what information would we have to know about these shapes? So in order for, let's say, these two triangles to be congruent to each other, what would we have to know? These two quadrilaterals, what would we have to know? Hopefully, you said that we need to know if the sides are all congruent to each other. And we need to know if all of the corresponding angles are congruent to one another. Okay, so in order to tell if these two triangles are congruent or if they're equal, that means they're the exact same shape, we need to know all three of their sides are congruent and all three of their angles. Same would go for a polygon. Okay, we would need to know that the corresponding sides are congruent to each other. Okay, and we need to know if all four of those angles are also congruent to one another. Okay, so be thinking about that as we go through today. Okay, we're going to focus majority on triangles today. Okay, congruent triangles. And if you remember what I just said a few minutes ago, that these two sections are called congruence shortcuts. Okay, so that means that I could need less information to determine if these two triangles are congruent. Because right now, I need a total of 6 congruent parts in order to say these two triangles are congruent. I need all 3 angles, and I need all 3 sides in order to say that. Okay, but now today we're going to have congruence shortcuts for triangles so that we don't need to figure out all 6 pieces, because that takes a lot of time and effort. And we like to be lazy, right? All right, the first congruence shortcut, now remember these are just for triangles. Okay, we call this the side-side-side congruence conjecture. Okay, and the side-side-side congruent conjecture says that if the 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent to each other. Okay, so notice that I have 3 congruent markings. Side BC is congruent to side YZ. Okay, I also know that AB is congruent to side XY. And then finally, I know that AC would be congruent to XZ. Okay, so now that I know that all 3 of these sides are congruent, then I know that all 3 of the angles are also congruent. Okay, so this is a shortcut. If we know all 3 sides, then we can say these 2 triangles are congruent. So now we can say triangle, let's draw a triangle there. ABC is congruent to XYZ because of side, side, side. Okay, so that means all of the angles, all of the sides are congruent. I'd for sure have a picture written down in your notes. The next congruent shortcut. This says, this is the side angle side, or the SAS, side angle side. If 2 sides and the included angle, that is key, the included angle. Notice that we said side angle side with the angle in between. That's what that means. Okay, if we know that 2 sides of one triangle and the inside angle, the included angle of another triangle are congruent to 2 sides and the included angle of another, then the triangles are congruent. So let's talk about this. Notice that I have side AC and BC. I have YZ and XZ. And then I have this angle C and this angle Z that are congruent to each other. And notice that C and Z are both in between those two congruent sides. So that's the key here when we're talking side angle side, is that angle is in between those two congruent sides. Okay, it is important. Okay, you're going to notice that when we get to a couple other conjectures. Okay, that angle has to be in between in order for us to say now that these two triangles ABC and triangle XYZ are now congruent by side angle side. So that means angle A and angle X are congruent, angle B and angle Y are congruent. That means this third side, AB and XY, are congruent to each other. So now, once we have a shortcut, we know that all of the other pieces are congruent as well. Okay, this one is key because the angle has to be in between. Notice that that angle in red, C and Z, are in between those two blue congruent sides. We also have shortcuts that come up that do not give us enough information. So this is the side-side angle one, and this is not a congruent shortcut. You're going to have to add this to your notes. Okay, but SSA is not a congruent shortcut. Okay, so side angle side is a congruent shortcut, but when that angle is not in between those two congruent sides, we need more information. Okay, this picture shows a situation where it could not be congruent to each other. Okay, we have our two congruent sides here, our two congruent sides here. Okay, notice that that angle is not in between like the last one. Remember, we had this angle and this angle were congruent in our side angle side. But notice that that angle 45 is not in between. So whenever that angle is not in between, we need more information. Okay? Yes, these two triangles could be congruent, or two different triangles that you're trying to prove, but we need more information on top of that. Okay? Obviously, these pictures show that they are not congruent. It's pretty obvious. Okay, but SSA is not a congruence shortcut. Okay, we need more information. Okay, if it's one thing, if you need help remembering SSA backwards, okay, is a naughty word. Okay, so be thinking about that. Okay, and yes, I have had people write that on tests the backwards way before without knowing, which it's fine, it happens. But SSA is not a congruent shortcut for many reasons. All right, another congruent shortcut that works. If we have two angles and the included side, so kind of like the opposite of what we just talked about. Okay, so the included side this time, then the triangles are congruent to each other. Okay, so notice that the side is in between those two congruent angles. Okay, and I'm actually going to put hash marks on mine. I think that's easier to represent congruency. Okay, so whenever we have that side that's in between, that is also a congruent shortcut. So now we know that the other angle obviously is congruent, C and Z. And then we know that the other two sides would be congruent to each other. Make sure you're writing down pictures, writing down your notes. SAA Congruence Conjecture, side angle angle. This is one that's always a tough one for people. because it's very similar to the SSA congruent shortcut, okay, which does not work. So the SSA, if you remember, that one does not work. So people get kind of easily confused with these. Okay? So when we have two angles and we have one side, okay, then we have the two triangles are congruent. Really, anytime you know two angles and a side, it's going to be a congruent shortcut. So I'm going to add these here. So notice we have two angles and this side is not in between. Okay, so notice this side is not just on the outside, that's fine. Okay, then we call that the side angle congruence shortcut. Angle is not a congruent shortcut. Okay, so angle is also one you maybe want to add to your notes. Okay, but it is one that does not work. We need more information. Okay, and this is the best picture I have to show you guys. If we have an equilateral triangle and another equilateral triangle, look, I can draw them small or big, and all their angles are still the same, but they're obviously not congruent. So I'd need more information. I'd need another side, or I'd need something else. Okay, so angle is not a congruent shortcut. Side is, but angle, we'd need more information. All right, so here I just kind of summarized the shortcuts that work and the shortcuts that do not work. Okay, you could also, if you want to write this down, the side angle one, you could also write it this way. Okay, but typically we write it side angle. It's not wrong, but just so you know, that's just another way of writing it. So write these down if you need like a little summary of the ones that work and the ones that do not work. All right, looking at this figure, we have to determine if these two triangles are congruent, and we need to state why or why not. So I notice here I have congruent angles, I have congruent sides. Okay, so I've given two pieces, but I also notice that they share this segment here. So if they share that segment, obviously that part is congruent if they share it. Okay, so looking at my top triangle, I notice that I have side angle. And looking at my bottom part, I notice I also have side angle. I kind of just go around in a circle. Start with one and work my way. Now, is side angle a congruent shortcut? No. Okay, so we'd have to write cannot be determined. We'd need more information because SSA is not a congruent shortcut. Okay, so this cannot be determined. Yeah, they might be congruent, okay, but we need another piece of information because side angle is not quite 100% a shortcut. Number two, very similar where we have the triangles right next to each other. I have two congruent angles on both, and then again, they share this side, so that means it has to be congruent. So looking at the top triangle, I see that I have angle, side, angle, angle, side, angle, and I want to check the bottom one to make sure it's the same, and I have angle, side, angle here. Okay, so these ones, yes, they would be congruent by angle, side, angle. Okay, you always want to make sure that your congruent shortcuts match in both triangles, because if one's angle, side, angle, and another one is side, angle, we need more information. Number three, Looks like we like these ones that are right next to each other like this. Okay, so when I see these right next to each other like this, I can say that they are congruent. So notice that I have all three sides in this triangle, all three sides in this triangle. So yes, these triangles are congruent by side, side, side. Right here, I have an angle and an angle and a side and a side. Take a look at this picture. Do you know anything else about them? Hopefully you notice that we have vertical angles. Okay, so I actually have angle, side, I have angle, side, angle. And I have angle, side, angle. Okay, and so that would be, yes, they are congruent by angle, side, angle. All right, looking at this picture here, I have congruent sides and I have congruent angles. Do I have anything else? Hopefully you said no. Cannot be determined. We need at least 3 pieces determined. I'm talking and writing. We need at least 3 pieces in order to state a congruent shortcut. So we need more information. All right, here I have 2 perpendiculars, which mean they're congruent. I have a congruent side. I also have vertical angles here. It looks like it's angle, side, angle, and angle, side, angle. So you should have said yes, they are congruent because I have angle, side, angle. Looking at number 7, if you're not writing these down, I highly recommend you start writing them down, going back to the other ones. Here I have a side, an angle, and a side. So I have side, angle, side. Over here I have a side, and an angle, side, side, angle. Notice that they did not match up. I'll erase my marking so you can see it a little better. Oops, I guess I'll erase everything and rewrite it. This one was side, angle, side. This one was side, side, angle. Notice this angle was not in between the 2 congruent sides like this one was. Okay, so this one is no, cannot be determined. All right, this one's real quick. Notice we have all 3 congruent sides of one triangle and all 3 of another. So you should have said yes, they are congruent by side, side, side. Here we have 2 congruent sides on both, and I see vertical angles. I notice that I have side, angle, side, side, angle, side, side, angle, side. So you should have said yes by side, angle, side. Last one. We have 2 congruent sides, and since they line up and match right next to each other, I can say that side's also congruent. So you should say, yes, they are congruent by side, side, side.